what is the equation we should use? This is chapter 4, still chapter 4. Okay. Alaikum Assalam. We are in chapter 4 question. So the forces are given on a boat. The mass of the boat is given. There are, one, two forces only, right? The other forces are vertical forces. They will balance out and cancel. Forces are given, mass is given. Ask him for the acceleration. So you should remember Newton's second law. Net force is equal to mass into acceleration. So net force we can get, mass is given, acceleration is the only unknown. Yeah, acceleration therefore, because you will say this is the Newton's second law. So acceleration will be net force divided by the mass. It's just so there are only two forces, because all the other forces are vertical forces. They will cancel anyway. Even he's giving us a lot of help. He's telling what equation to use. There are only two forces, this and that. So I will say the net force will be the addition of the two forces. One is called the keel. The other one is called the sail. So you have to add them and divide by the mass. Everything is given. But the only thing is vector. It's not just simple addition, but vector addition. So you should give the respect. Okay, vector is a vector. You cannot deal with it with like anything else. So when you add vectors, x components are added separately, y components are added separately, then you get the answer. So F keel, that one over there, he's even, lots of help is given to you. He's giving the x and y component. 989 is the x component negative and the y component is 0. And this guy, keel, that is also, well, it's not exactly simplified. You have to do some calculation. That's not a big thing. You just take the calculator and do it. Divide by m. M is 671. Right. Somebody has to help me. Calculator. Let's go step by step. Give me this. Also, okay, and this one 971 571. You see, I mean, okay, let me not jump ahead. Let me go step by step. How do you add vectors? You only add the x's, that will be 0. You only add the y, it will be 571, and divide by 671. So now somebody again help me. 0 divided by something is 0. 571 divided by 0. Okay, let me show the steps. 0.85. That's the answer. That's it. We are done. Is it there? Yeah. Okay. So, this is where we make use of our vector knowledge to answer the question. And all right, now let's go to the next one. A block of mass, 10 kilogram, is pulled up a rough incline of angle theta equal to 40 degrees with a force of magnitude F equal to 100 Newton parallel to the incline. As shown in the figure, the kinetic friction force between the block and the incline is 37. Even the picture is given to you. So all you have to do is again apply the Newton's second law. But this time you're not going to do x and y together, right? Because it's not given like that. So we just apply in the x direction, apply in the y direction, see which one will give us the answer. Maybe we need both, we don't know. But the question is to find n, right? N is in the y direction. So naturally, without wasting the time, let's go to the y direction equation. That means net force in the y direction equal to mass multiplied by acceleration in the y direction. Especially this equation is going to be easier than the x direction. Why? Acceleration in the y direction is 0 because moving, this is the x direction. It's moving along the x direction only, no motion at all in the y direction. So good for us. Whenever you have a 0 for any term, that make it easy for us. And n is in the y direction only. Hopefully, we can answer it very quickly. Let's see. Right. So how many forces we have? 1, 2, 3, 4. So you have to net force mean you have to cannot leave out any force, right? We have to bring all the forces. Sometime it will be 0 from one force in the y direction. It will not there because if it is in the x direction, it will be 0. So anyway, just to make it clear to you, I will say because the sum of all the forces, I will say start with the n, the y component of n plus f. I'll go this way, okay, so I don't miss anything. Y component of f plus y component of mg plus y component of friction equal to this side is 0, right? M multiplied by 0 is 0. So that side is 0. Yeah. Net force of y equals to net force of x. No. I am doing this equation. Why are you jumping to x? All right, okay. I'm saying this is Newton's second law. It is not something you make up. Okay, you have to go from the Newton's second law, which says net force in any direction is equal to mass multiplied by acceleration in that direction. So I have chosen the y direction because I know n is in the y direction. So I like to get an equation with n in it. Right. Now this will be plus n because it is in the positive y direction. And what about f? That will be 0 because entirely in the x direction. It has no component in the y direction. And what about mg? Here we have a little bit, because if this is theta, mg is making an angle of theta with the y-axis, negative y-axis. So the y component of mg will be mg cosine theta, and with the negative sign because downward. This is one of the places where you students get confused because you keep teaching me x component is cosine theta and the y component is sine theta. Now all of a sudden you are changing, right? But you know better why I did that, because the angle that is given to us is not with the x-axis. Mg is making an angle of theta with the y-axis, so everything flips. Okay, so that's fine. Now what about this? This is in the x-axis, right? Negative, but it can be 0. You got it? Okay, now we are approaching the solution. So the only thing is this 0, 0, if I do some algebra, m equal, it going to the other side, so n is equal m equal, just a matter of substitution, right? So you substitute and tell me the answer. You should get the one of the answers. I don't know. So somebody do the calculation. 10 multiplied by 9.8 multiplied by cosine, how much? 40. So this one. See, we don't even need this, right? It's there. Yeah. Yeah. Okay. This is your positive y-axis, right? So theta is the angle mg makes with the negative side. So its component will be downward. The x component, y component of mg will be, yeah, perpendicularly down to the surface. Okay, so it's, right. All right. A block of mass 10 kilogram is pulled up a rough incline of angle theta equal to 40 degrees with a force of magnitude 100 Newton parallel to the incline as shown in the figure. The kinetic friction force between the block and the incline is 37. Coefficient of kinetic friction mu k is equal to, right. So this one, in addition to the Newton's second law, we also need to know, because this coefficient of kinetic friction, this mu is coming in. We are asked to find the mu. This equation. Okay, that's in the formula sheet. It's not that it is not there. I mean, it is there. So, is n given to us? No. We have to find the n. Okay, it is the same data. I don't think the same data. It's different data. Same data. Well, let me go up. Yeah, exactly same data. That means I have already found n from the previous, but don't assume anything. Okay. So I don't have to repeat the calculation for n. I have already found n. So I know n, and I know given in this question, so I have to find mu k. Okay. Right. This is like one question broken into two. Okay. So Fk is 37 and n is what I found. I provided it the same data, okay, that you have to make sure about that. Divide by, what did I find for that? 75? Somebody answer this, please. Okay, the first. All right, good. We can now go to the next question. Two blocks of masses, 7 kilogram and 9 kilogram, are connected together by a light string and rest on a frictionless level surface. A second string attached only to block B has a horizontal force of 30 Newton applied to it. Both blocks accelerate together. Find the tension in the string between the blocks T1. All right. Okay. If I take only the A, the A has the tension T1 acting on it to the right. And of course, there is normal force from the table, from the floor on this NA, and the gravitational force MAG. We have to put the AB because this will be MBG, right? It's not the same M, so you should have the, so the, and this has T2 to this side, T1 to this side. That is the free body diagram for B. This is the free body diagram for A. Now, the question is to find T1, right? I can either apply the equation to this or this. If I apply the equation to this, this says, in the x direction, there's only one force, T1, right? So the question is to find T1. So rather than applying to B, I will apply the Newton's second law to A, looking at all the forces acting on A. So I will say for A, the block A, I will apply the Newton's second law in the x direction. the x direction, because T1 is in the x direction. So these will not come. So the net force will be only T1 in the x direction, and it is entirely in the x direction, equal to m a, mass of A, multiplied by its acceleration. Both A and B have the same acceleration. Have we solved it? No. We don't even know the acceleration. What do we do? We can apply the equation for B. I will get another equation, but in that equation, we will have T1 also. So we'll have two equations, two unknowns, slightly going to give us hard time. It's not that we cannot do it, we can do it. But what I can do is to treat the whole thing as one system. This both M1 and M2 as just one object. It is okay to do that as a system. The reason is both MA and MB. Both have the same acceleration, same magnitude, same direction. So for this one object, we have only T2 in the horizontal direction. Of course, in this direction, you will have NA plus NB, and down we will have MA plus MB times G. Those are vertical forces. But when you take the whole thing as one system, the only horizontal force is this. What about this? They cancel for the system. On A, there's a T1 to the right. On B, there is T1 to the left. They will cancel each other. So for the whole system, in the x direction, we have only one force. So I will again apply the Newton's second law for the system in the x direction. So this will be only T2, and the mass will be the total mass, and the acceleration is the unknown. Now here, T2 is given. This is all given, so I can find the acceleration. It will be T2 divided by the total mass, which is 30 Newton divided by 7 plus 9. Somebody tell me what it is equal to 50? Yeah, give me the final answer. 50.375. All right, 1.375 meter per second square. All right, is that right? There? Oh, sorry, 1.875 meter per second square. Now you bring it and put it in here. So T1 is equal to MA, which is 7 kilogram, multiplied by 1.875, said, right? 1.875. What do you get? 13.1, which is E, right? Total significance. It's chapter 4. Oh, really? Good. So good. I will repeat. Okay. Here. Okay. Now we want to do this. Fine. So question is to find T1. So I can either apply the Newton's second law for A, or you can apply it for B. I already did for A. So in the x direction, right? So the only force in the x direction on A is T1 in the x direction. So m into A, the mass of A multiplied by acceleration of A. But the problem with this is I want to find T1, but A is also not known. Don't know that the acceleration is. So we can go to B and apply the equation. In that also we will have two unknowns, T1, also the acceleration. You know, we can solve it, no problem. We have two equations, two unknown, we can solve it. But I have a better way. I can take these two as just one object. And in that one object with a mass of ma plus mb, so the gravitational force will be down, and there's a normal force from both of them is Na plus Nb. In the x direction, I have only T2. What happens to T1? Cancel, it become internal forces. On B, there's a T1 to the left. On A, there's a T1 to the right. So when you consider them as just one object, the T1 will not come into the picture. So it becomes very easy for us. So net force in the x direction for the system is T2 only, and m will be the total mass, and acceleration is the same acceleration. Then I worked out what is acceleration. I found this answer, and I bring it here, and now I can solve for T1. Okay. Okay, this one. A 5 kilogram block is on a rough level surface and is attached by a light string to a hanging mass B, where the string passes over a massless, frictionless pulley. If the tension in the connecting string is 35 Newton, so there is tension, it is T, and it is 35 Newton. It will be T on this to this side, on this upward. Okay, good. So tension is given. And the kinetic friction force between the block A and the level surface is 10 Newton. So here we have the kinetic friction force, which is 10 Newton. That's not given. What else is given? The mass of A is given. So MA is 5 kilogram. These are the things that are given. Find the magnitude of the acceleration of the block. So he's asking us to find the acceleration. How do I do that? Yeah. Yeah. So you start with Newton's second law, right? You apply the Newton's second law on B first, right? To find the acceleration. Okay. Say, well, the question is to find the acceleration. What about, why not you choose A? Do I know the mass of B? No. So if you apply to B, you will have an unknown, two unknowns. Mass of B is unknown, also the acceleration which is. So applying to B is not going to help us. A. Okay. Yes. Yeah. What is it? It's Newton's second law. Net force is equal to mass into acceleration. Okay. Start like that. You. Okay. Yeah. But better go slowly. Now this is you are applying in the x direction, right? So that's why these forces does not matter to us. The only force in the x direction is T and Fk. So for A, right? So this will be T minus Fk. That's the net force in the x direction. This is troubling me. So equals mass of A, right? Multiplied by the acceleration. So I think that's enough for us. The only unknown in this equation is A. So we can just solve it. A is equal to, like you said, T minus Fk divided by mass of A. Okay. Yeah. But anyway, I mean, yeah, with this done, acceleration of the blocks. So assuming it has the same acceleration for both. Whether you find the acceleration of A, whether you find the acceleration of B, they're the same answers. So I don't know. Shall someone do it for me? T is how much? 35? Right? Oh, 35. Minus 10. Divide by mass away, 5 kilogram. So which is 25 divided by 5. This is 5, right? Okay. You don't even need a calculator for that. All right. A block of mass, this is a straightforward question, okay? Just what is the work done? You need to know the equation for the work done by a constant force to be equal to F cosine theta into the delta x or d or whatever you want to call it, the displacement. So you know the force, substitute. The magnitude of force is 20. And theta is the angle between displacement. This is the displacement and this is the force. This angle is the same as this angle, and that is given as 60. Okay. Cosine 60 multiplied by delta x is d, 2 meters. I don't know, somebody tell me what the answer. Yeah, it is 20, right? Because cosine 60 is half, same as sine 30. So these two questions, we don't need a calculator. The 60 kilogram runner has a speed of 3 meters per second at one instant during a long distance event. What is the kinetic energy? This is also direct definition question. Kinetic energy equal to half mv squared. So half m is 60 and speed is 3 and squared, there it is, 15, and this is 30 into 9, 270 joules. Yeah. So chapter 5 goes like that. You will see the first question is what? Just now you start chapter 5. First question, this one. Work done by a constant force, usually a direct question. Second question, chapter 5, on kinetic energy, again a direct question. And then you combine the work done and the kinetic energy. We have something called net work is equal to change in the kinetic. I hope it is this question. I didn't even read the question, I'm just assuming it. Yeah. Right. There is a box sitting on a smooth table at rest. So initially it has a speed of 0. Was pushed. So there's something happening, a process, by a horizontal force F, a distance of 2.5. So there is some work is being done by that force. Okay, the only horizontal force. So vertical forces are balanced. So the net work will come from only the horizontal force, because the other vertical forces will do 0 work. They will cancel. One will be positive, one will be. Actually, the vertical forces will do 0 work. You know why? Displacement and the vertical force has an angle of 90 degrees. Cosine 90 is equal to 0. So only the force that is parallel to the displacement, which is our force, will do a work. So the net work will be only the work done by that force. He's asking, when you do this work, the kinetic energy increases by 15 joule. What is it then? He's giving us this change in the kinetic energy plus 15, right? Increases. So this is given. And net work I can write is only from the applied force, F into cosine theta. Theta is 0, by the way. So cosine 0 will be 1. Because theta is 0, cosine, multiplied by the distance, 2.5 meters, is equal to 15. This question is made too easy, then it looks like difficult. I mean, it's just confusing us. Because instead of giving the velocity and so on, he's just giving the whole thing. What is the change in the kinetic energy? So that is 15. So the only unknown in this equation is F. And the question is to find the F. Okay. So F is equal to, this is 1 because theta is equal to, is the same direction as the displacement. This cosine 0 is 1. So F is equal to 15 divided by 2.5. Whatever it is. What do you think it is? 6, 6, right? 6. Yeah. Because, yeah, 6. 15 divided by 5 is 3, but it is half of 5 is 2.5, so it is 6. Why cosine 0 is 1? Because it is so. You have to remember. I mean, you can use your calculator and figure it out. You just remember, it's easy to remember. Cosine 0 is 1, cosine 90 is 0. On the other hand, sine 0 is 0 and sine 90 is 1. Oops. Don't mix them, okay? Well, you can get it from your calculator. I'm posting it anyway, so I'm recording actually. Somebody asked me to record it. All right, let me move on. This is also the work kinetic energy theorem, or you can use it, solve it using the energy equation as well. But since I will do it the same, network equal to change in the kinetic energy. So the box is being pushed by a force from this man. Okay, so there is a force. Okay, now we can forget about this man. There is a force which is pushing the box. And the mass is given. Is the initial velocity, at one point in time is 0.900. He's been pushing it with a constant velocity. At one point, before it encounters some rough surface, before it hits the rough surface, its velocity is 0.900. And this length of this rough surface is also given to us. He exerts a constant horizontal force of 200 Newton. The force is also given to us. If the speed of the crate is 0.500, when the crate comes to this point, the velocity final is 0.500. Okay, from 0.800 because of the constant force, but it has become less. Why do you think that happened? The friction. Okay, the friction force probably greater than the, not probably, is greater than the 200 Newton. That's why it has reduced, because the net force is in the left direction. I mean, our question is to find that friction force. So let me use another color to show the friction force. So there is a right force which is 200 Newton, and the left direction force which is the friction force which we don't know. And initial speed and the final speed is given. You should remember this equation. Network is equal to change in the kinetic energy. So, of course, there are other forces. I'm not telling there aren't other forces. There are other forces. But luckily, those forces will be perpendicular to the displacement, the normal force, and mg. Individually, the work done by the normal force will be 0. The work done by mg will also be 0. Reason, 90 degrees. Cosine 90 is 0. So the net work will be only the work done by the applied force by the man and the friction force by the friction. So this is the left-hand side, equal to change in the kinetic energy. You will write half m v final squared minus v initial squared. See, if you look at this equation, we know everything. I have to expand it more. Let me tell you why. Because the question is to find the friction force that is inside this. So I have to go one more step. Work done by the applied force will be F into L. Cosine theta is 1 again, 0 degree. And the work done by friction force will be minus Fk into L. Why is minus? Because cosine 180. This is cosine 0 is plus 1, but the angle between Fk and the displacement is 180. So cosine 180 is negative 1. So the friction force does the negative work, and the applied force in the same direction as the displacement does the positive work, equals. Now look at this equation. We know everything in this equation except, let me use another color, Fk. Very good. So that means I can solve it. Do it with your calculator. Okay, don't worry about doing the algebra. Just, yeah, call it X and you solve it. Let me put the numbers first. Okay, yeah, let me just do it anyway here. F is what? Somebody help me? 200. I'll do the number substitution. L is? Okay. I'm going to call it X, okay, because that will be helping us to put it in the calculator. X. L is again 0.650 equal to half. M is equal to 80. Now, when you are doing the exam, you don't have to do this, but this is for making it clear. So here you are, you know, you can just type everything because we want to save time as much as possible. Oops. What did I do? 80 mass. V final, somebody help me, please. 0 final, right? Okay. Minus initial. Right. Now we take the calculator. Did I have to bring, okay, let me go to desktop. Okay, here is my calculator. Now I can do it. Tell me, 200 multiplied by 0.65. Here is not needed. Hopefully it's fine. Minus subtract x alpha x multiplied by 0.650 equal half. Can write 0.5, save time, multiplied by 80, multiplied by start left parenthesis 0.5 squared minus 0.9 squared, close the bracket. That's it, right? Now tell it to solve. Shift calc. That's not the answer, you know that, right? Press the equal button, 234. A, right? It's there. Good, great. Okay. Shrink it a little bit to magnified. You know, I'll not even talk about this, you know what. Number 17. That's also, you know, you say the same question again and again. But now we come to, this is a definition question, okay? The first one is, he is asking not to apply the theorem or the conservation principle. What is the change in the potential energy? So always read the question. So something is here and comes there. What is the change in the potential energy? Delta potential energy change. Zaid, please. Okay. I cannot concentrate if you chattering. Okay, fine. Change in the potential energy is equal to mg delta y. So this question is definition question. Okay, so that's just, you know what is the formula for the potential energy. So this is the change in the potential energy. Just ask him what is the potential energy change as it goes from there to there. So it will be, this will be your delta y. So always read the question. Oh, I didn't read the question. Did you see that? C to A. So delta y is not this. Completely wrong. Delta y is this. C is the initial, A is the final. Yeah, exactly. So please read the question. See, I'm being the one who made the question. I was very careless. I think I know what the question is, but you have to read the question, okay? Please read the question. Right. So it is from C to A, not from A to C. So now comes the substitution. M is 50, G is 9.8, and delta Y is this gap, right? The final position, which is 155. And now, you know, negative will come automatically, right? Because we use what is delta Y mean? Final position minus initial position. Don't put another extra minus, okay? Then everything will go wrong. 155 minus 230. Yeah. Which one? That is, okay, A. Right, okay. Okay. Wow. You see, I made a big mistake. What is the SI unit for mass? Kilogram. What is it given in? Gram. So I should say 50 divided by 1000 to make it into kilogram. That will give me negative 37. Okay. That's rounded to two significant figures. Right, next one. Now this one, you know, is not definition on the what is potential energy change, but we are going to apply the conservation of energy equation. So you don't right away assume it is going to conserve. The best thing is to write in full form the energy equation. This is the, I'm sorry, pardon. Which one? This one? Here? Plus. Change in the kinetic energy plus the change in the potential energy. Right? Change in the potential energy plus the change in the kinetic energy is equal to any work, external work and the non-conservative work. If they are zero, I'm not going to assume right now. I will just write the general equation. Then I will read the question and see whether I can put them into zero. Then it becomes conservation of energy. Only when they are zero, it is conservation of energy. I don't know anything. I didn't even read the question. I only know I'm going to use this equation to solve this problem. That's all I know. I didn't even read the question. I don't know nothing. Okay, so, okay, what is the question now? There is a bead at point A, and it has a speed of, at point, so initial, so equal to 20 meter per second. And on the track, and it goes down in a frictionless track. And when it comes here, it has a, the question is, what is the speed when it comes to this point? That is the question. The initial speed is given. When come to the point C, that is my final. Tell me what the final speed is. So I'm going to use this. You know, we know kinetic energy will have the speed. Potential energy will have the height. y displacement. Okay, so those are given to us. So the speed will come, the final speed will come in the equation. And let's look at this side. Our system is the bead plus the track plus the earth. For this system, we don't have any outside force. Is anyone pushing or pulling the bead? No, it has some speed, somehow it got before. At this point, there are no other forces except the gravitational pull. And of course, there is a normal force that will be doing zero work. It is always perpendicular to the displacement. The normal force is perpendicular to the surface, so that will not do any work. So the only force is the gravitational force that is going to do, but that comes as the change in the potential energy. So you don't bring the work done by the gravitation. Only thing what we have on the left side is work done by any external force, which is zero, because we do not have any external force. And do we have any non-conservative force? No, because he's saying it's friction free. The only non-conservative force you have to worry about is the friction. So friction, this is also zero. So we have zero equal to, on this side, potential energy change is mg delta y. You can just write it like that. And the kinetic energy change is only the bead, half m v final squared minus v initial squared. Now, we do a small trick here, which is I will say I will multiply by m this side also to get rid of the m. So the mass of the bead is not given to us, right? We don't need it because it is, you are dividing by m both sides, right? You know the trick. When you divide by m both sides, you are not changing the equation. So m cancel with m. Here, even if the m is not there, it doesn't matter. 0 divided by m will be 0. So we get it to be 0 equal to g delta y plus half v final squared minus v initial squared. That's it. Now I can put this into a calculator and find the answer. Everything we know except this guy. So let me make it in, I will just put it in, what do you call, in red. Okay. In the calculator, I will make it X. So this is the only unknown. The rest of them we know. Let me go to the calculator. I will clear what is already there. Then I will type in 0 shift. What did I do? 0 shift, not shift, alpha calc. Okay, equals G is 9.8 multiply delta y. Delta y is what? From A to C, right? 160. Let me do y final minus y initial. So 160 minus, let me not cover the equation. Oh, I put 60. Let me correct it. 160 minus 200. Close the bracket. Right. Then plus. For half, I can type 0.5. That is faster. Then multiply by open bracket. V final is our unknown. So I have to call it x squared. Don't forget the squared. Minus V initial is how much? 20 meter per second, right? Oops, I lost my calculator. Okay, 20 squared. Close the bracket. That's it. Just make sure you didn't make any mistake while typing the equation. I believe I didn't make any mistake, so I will go shift calc. That is not the answer. That is from previous calculation. You have to see the L minus R. How do you get it? Press the equal button. Yeah, 34. Is that the answer? Yeah. Okay. Right. Good. So we can go to the next one. We get rid of that. 60 kilogram skier starts from rest from the top of a 50-meter high slope. If the work done by friction is that much, what is the speed of the skier on reaching the bottom of the slope? Right. So we can just sketch a figure. There's no picture, right? So sketch a figure very quickly, just to make sense of the question, so you know you have understood the question. That's a skier. See, it comes down the bottom of this high slope, and here top of 50-meter height. That means this is 50 meter. So this will be 0 meter. Y value is 0. Here y value is 50. Only the height, high slope. If the work done by friction is given, what is the speed of the ski on reaching the bottom of the slope? So again, I always like to start with this, but quickly make whatever is 0 to be 0. So what happens here is all the potential energy is transformed into kinetic. No, there is a friction. No. So we don't have conservation of mechanics. This is not 0. This is 0, yes, our system. We don't have anyone pushing or pulling the guy. He's just coming by himself under the friction and the gravitational force. Right. This is not 0, but this is 0. For this, what do I write? The work done by non-conservative force. This is given to us straight away. I don't have to say a friction force multiplied by the distance. The whole thing is given to us. So this is equal to minus 17. Let me be complete. So I will do this. I will say 0 minus 17400. That is the left hand side, and the right hand side mg delta y. That is the kinetic energy is there first, right? So let me keep the same order. So kinetic energy will be half m v final squared minus v initial squared, and this guy will be plus mg delta y. All right. Right. The question is v final. Is that the only unknown in this question? Yes or no? Yes. Otherwise, we cannot solve it, right? It better be. So only v final is the only unknown. Everything else we know. Mass is given, 60 kilograms. V initial is given, rest, 0. mg delta y is given, 50. So it's a matter of substitution. Let's go to your calculator. Clear whatever is there. 0 alpha equals, not 0. Why did I put 0? 0 minus, forget about the 0. I'll put negative. I'm using this negative, okay? Probably this is also okay, but I want to be safe, okay? So 17400 alpha equal 0.5 multiply 0.5 multiplied by m. M is equal to 60 multiply start bracket alpha x squared minus v initial is how much? 0. So anyway, I have started the bracket, so let me complete it. Plus m is again 60 multiplied by 9.8 multiplied by, no, there's no need for bracket, is already given. But I better put the bracket. You know why? First of all, put the multiplication. If you put just minus 50, if you put minus 50, calculator will think you want to subtract, not subtract, this 9.8 multiplied by negative 50. Do you understand that? If you just put subtract 50, that is something else. It is 80 minus 50, which will be 30. That's not what you want, right? 80 multiplied by negative 50. Delta Y is going down. Yeah, it's going down. So the potential energy, delta Y is negative 50, not positive 50. Okay. And another thing is, if you just put minus 50, everything will be wrong. So it will calculate 80 minus 50. Calculator will think that you want to do the 80 minus 50, right? So those problems are there. So that is why I did this. Put it in the bracket and minus 50, so it understand 9.8, 60 multiplied by 9.8 multiplied by negative 50. Okay. Now I'm fine. All you have to do is to ask the calculator to solve it. Shift calc. That's not the answer. You have to press the equal button. So the answer is 20D. You know this answer, right? Let me not bother with that. 21. Okay, this is on the energy thing, but here what you're going to say is, okay, first let me read the question. So there's a block of mass which is at the top of the slope, and there's a spring at the bottom of the slope. Then you release it. When you release, what happened? This guy comes down, hit the spring, and compress the spring to its maximum. Then, it doesn't stop, it will be pushed back. But I am going to take this as my initial when it is like that. And the final is when it is the moment, at the instant when it is fully compressed. The spring is fully compressed. That is my final. Then things happen after that, but I don't care. My initial is here. My final is the moment when it is fully compressed. Because the question tells you some data. When it is fully compressed, we know the kinetic energy of the block is 0. Because what happened when it comes here, it will have certain speed, right? Then it will be pressing the spring. Then the speed will reduce. When it becomes 0 only, it will start the backward journey. So we know when it is here, the kinetic energy is 0. I already answered the question, one question, because the question is, we have to tell what is the kinetic energy at the point 2, the final. What is the potential energy? What is the kinetic energy and the potential energy when it is in the final stage, in the number 2? That is the question. You already got the kinetic energy. How do I know that? Because maximum compression. At the maximum compression, the block will come to 0 velocity. So the kinetic energy of the block is 0. Right. So the answer can be A because this is correct, can be C because that is correct. So these are all gone because kinetic energy is not correct. So we have eliminated, so we have either A or C. That means now I have to find the potential energy also. So he is telling us this. Kinetic energy initially, the block is 196. Kinetic energy only coming from the block. Potential energy of this spring is 0. Why? It is relaxed. Potential energy is given by this equation, right? This is the spring extension or compression, that is 0. The potential energy initially is 0, is given to us. And the potential energy gravity is given to us as 45. It is given to you, okay? So everything is given, it's somewhere here, 45 joules. So we have 196, 0, and 45. What is the total energy? Let me write it properly so I can do the calculations. potential energy is 0, potential energy, spring potential energy is 0, gravitational, okay, I didn't align. So what is the total energy? 6 plus 5, 11, 10, 14, 241 joule. This is my total initial energy. Now I have to find what is the potential. Here it is given 3. Is given to us. The gravitational potential energy is 3. This is not given, but I know because at maximum compression, kinetic energy is 0. Only thing I don't know is this. What is the spring potential energy? That's the one we don't know. But it's not a problem, right? We will say initial energy total is equal to final energy, conservation of mechanical energy, because there is no friction, no external forces, all are these conservative forces inside the system. So you will say 196 plus 0 plus 45 is equal to 0 plus x plus 3. Find x. It will be 241 minus 3. 238. So A is the correct answer. C is out. Okay, this is the last one. This is usually a straightforward question, I hope. What is the power? It's a bit different from the other exam paper. Change the speed from 1,600 kilogram sport utility vehicle from 15 to 40 in 4 seconds. So power is work done divided by time. Yeah, average power, not total. Average power is work done divided by the time, because during a duration, not at just one point, not instantaneous power, the average power. But here, potential energy is not changing. What is changing? Only the kinetic energy. So changing the kinetic energy divided by the time. So changing the kinetic energy will be half m v final squared minus v initial squared divided by the time. So we have everything. Just substitute half. M is 1600 and final speed is 40. Initial speed is 15 divided by time is 4 seconds. It's already in second. That's it. So I don't know what the answer is. Anyway, just I will stop now. Okay. Yeah. What did you get the answer to be? It will be a big number because it's in 5,000 something, right? So kilowatt will be just 275. Okay. Very good. So there's nothing like that. It's not like that, you know. Everything will come. How do you stop the? I'll stop sharing. It will stop. How do I stop it? Okay. Never mind. Anyway, I'll stop sharing. Okay. And stop recording. Stop.